Hello, Big Reds. This is Mr. Fischel talking. Right here, we're going to have a video about Unit 6, and this is to review for the test. So first of all, what I'd like you to do is to construct. Well, it doesn't have to be a big circle, just a small circle here. And I'm going to draw on a few different points, segments in here. So draw this in with me, please. And I'm going to call this A, B, C, D. Now, in this test, you're going to have to know vocab and how to solve problems. So vocab is important. So it's very important that you listen to what I'm saying, because if you're listening to what I'm saying, then you're going to know the vocab terms. So let's look at, first of all, a few of the terms. AC, A to C, is called a diameter because it's a chord that runs through the center of the circle. Next thing we have right here, let's say, what is BD called? BD is called a radius. The radius is a segment going from the center of the circle to the edge of the circle. Next type. What type of triangle is triangle BCD? Well, since B to C is a radius and B to D is a radius, this whole triangle is an isosceles triangle. Now C to D is also a chord like A to C is, but A to C we might say it's a diameter. C to D is just going to be a chord. Now, first of all, when we did our little circle folding, I don't know if you remember, but if you look back at the circle folding activity, we know that the circle folded 3 times to make an equilateral triangle. That means that this angle CBD, remember the middle letters of the vertex, was 120. And since this is an isosceles triangle, these two are the same length. All right, these two angles had to be the same. So this is going to be 30. This is going to be 30. Because 30 plus 30 plus 120 equals 180 degrees. Now ACD, angle ACD, is an inscribed angle. It's an inscribed angle because its vertex is on the circle right here. Let's zoom up a little bit more. Maybe that'll help. ACD is an inscribed angle. Angle ABD is a central angle. The difference is because ABD, the vertex is in the center of the circle. ACD, vertex is on the circle, right here. Okay, now we know that the inscribed angle is half of this arc and half of the central angle. So if this is 30, this angle is going to be 60 degrees, and this is not drawn to scale. And this arc AD is also going to be 60 degrees. So now a few other things that we did. Let's say if this radius here is 4 centimeters. And I'm going to zoom up a little more so you can see better what I'm writing. This is 4 centimeters. This is going to be 4 centimeters. If we were to divide this in half, make this 90, make this 90, that means this is 60, this is 60, and those at 30, 30, and this is 90. So this is a 30, 60, 90 triangle. And I'm going to make these, I'm going to label this, say this is E and this is F. And again, it's not drawn to scale. Well, this again is a 1, 2 square root of 3 triangle. So if this is 4, that means that this side is half of 4, so this is 2 centimeters. And this is 2 square root of 3 centimeters. This is 2 square root of 3 centimeters. Now if I wanted to know how long this chord is right here, I'd add these two together. So length of CD is going to be 4 times square root of 3 centimeters. And now if this radius was 4, the diameter is double that. So AC would have to be 8 centimeters. So we took 2 times 4 to get 8 centimeters. All right, I want to make sure everybody has everything written down right now. Okay. All right, now, going to construct, sorry about the blurriness here. I'm going to construct another circle here, actually a couple more circles. These circles don't have to be big. All right, so I'm going to make myself an inscribed quadrilateral. Remember, an inscribed quadrilateral means that all the vertices are on the circle. All right, now I'm also going to make an inscribed angle here. I'm going to label this A, B, C, D, E, F, G. And let's say that these two angles right here, this is going to be 120 degrees, and this will be 70 degrees. And let's say I want to figure out what angle B was up here, and I want to figure out what angle C was. Well, in an inscribed quadrilateral, the opposite angles add up to 180. So I could take 180 minus 120 to give me 60 degrees for this angle right here. Same thing with these two. These two add up to 180. So I take 180 minus 70. So angle B would have to be 110 degrees. Okay. This right here, let's say if I'm given an arc, let's say this arc is 78 degrees, and I want to figure out what angle F is, EFG. I know that inscribed angle is half of its intercepted arc, so I take half of 78, or 78 divided by 2, and that gives me angle F, which is 39 degrees. All right, we're going to stop right here, and then we're going to go on to section 2 in just a moment. So when you're finished with this, please stop, go on to section 2 of the video.